Hello students, this video is especially for the students, those who have passed recently from the 9th standard and obviously they are in the 10th. All of you know that we are having that new chapter in the 10th standard is chemical reaction and equations, and we cannot go further for this particular chapter if we are not very familiar with the formula of compounds. And all of you know that the compounds are made by the two kind of ions, and the ions are the charged species. As we know that there are two kind of charges in this universe, that is positive and negative. Positive charged ions are known as cations and negative charged species are known as anions. When these cations and anions combine, satisfy themselves and make compounds. And obviously these compounds will be the combination of plus and minus, and these plus and minus are satisfying themselves, as I have told you earlier. Before going to the formula, we have to know which cations and which anions are present in this universe, or what kind of cations and anions are present, and we have to learn them also so that we can make the formula of the compounds. So let us start the making of formula, and before that, by learning of cations and anions. Here I am going to give you the list of the cations first, and then I will be giving you the list of the anions. Let us have both the things together. Let us see the list of cations. Here you can see there are various cations which are having only one charges on them. One positive charge means the loss of one electron. Here you can see the cations which are having two charges on them, positive charges on them. That means they have lost their two electrons. And here it is the aluminium, which is most common tripositive ion, and this is having three positive charge on it, and it means that it has lost three electrons. So let us discuss one by one all of them. The elements which have lost their one electron in making the unipositive ions are: this is lithium, sodium, potassium, silver and gold. All of them are having unipositive charge. Magnesium, calcium, barium and zinc. These are the most common positively charged, dipositive charged ions, and aluminium is tripositive. Now let us discuss the cations which have variable valency. Now let me tell you first what you mean by the variable valency. Variable valency, as the name is indicating, it means the change in the valencies. All of you can see here, there is iron which is there with the +2 valency, and here this iron is having +3 valencies. These ions are always with the +1, +2 and +3 valencies in them and never change their valencies. But there are certain ions, there are certain elements are there which show the variable valency, and these are Fe+2 and Fe+3, Cu+1 and Cu+2, Pb+2 and Pb+4. Here it is tin+2 and tin+4. What we have to remember here is, whenever we have to name these ions are named simply by their names. Simply, like if it is lithium, it will be named as lithium ion. It is sodium, sodium ion. Potassium ion, silver ion, gold ion. Magnesium ion, calcium, barium, zinc ions and aluminium ions. Jabki while naming these variable valencies cations, we have to make sure that which valency is less out of these two. All of you can observe here, this is Fe+2 and this is Fe+3. +1, +2, +2, +4. So one of the valency is less and another one is bigger one. So the ions with the less valency, they will be suffixed as us along with their names. Like if it is iron, it will be named as Ferrous. Ferrous. If it is copper, it will be named as cuprous. If it is plumbum, it will be named as plumbus. And in the same pattern, it will be stannous. All we can see here, we are comparing only the charges present on them. +2, +4. Which one is less? +2. So this will be us. plus 2 plus 4. Which one is less? Plus 2. So this is us. Plus 1 plus 2. Which one is less? Plus 1. So it is us. Here it is plus 2 plus 3. Which one is less? Plus 2. So this is ferrous. On the same pattern, we will be having the another naming, that is for the more charge, the atoms with the more charges on them or the ions with the more charges on them, and that will be suffixed as ic. So if it is ferrous, it will be ferric. If it is cuprous, it will be cupric. This is plumbic and this is stannic. Here what is common? Ic, ic, ic and ic. So the charges which are having less in amount, they will be named as, the ions will be named as us as a suffix along with their names. And the another kind of charges which are more in number, the more charge will be named as the ic along with their name. So you have to remember this list so that you can better perform in the exams, because the questions will be asked like, write down the name of this FeO. So this FeO, here this Fe plus 2 and this is O2 minus. If it is Fe plus 2, so this compound is oxide obviously, but it is with the lesser valency Fe plus 2, so it will be named as ferrous oxide. In the same pattern, if I am having PbCl4, so this is Pb plus 4 and this is minus 1. So this PbCl4 will be named as plumbic chloride. So let us talk about the anions. Anions are negatively charged species, and these, on the basis of how much charge is present on them, we have categorized them into uninegative, dinegative and trinegative ions. If it is uninegative, it will be having only one minus on them. If it is dinegative, it will be having 2 minus on them. If it is trinegative, it will be having 3 minus on them. So here I am just reading out what are these charges. You have to memorize them. I will be giving you a very special sentence which will help you to memorize these in sequence so that you will recall them at the time of when you need them. So this is OH minus means hydroxide. It is named as hydroxide. Cn minus is named as cyanide. Br minus is named as bromide. Acetate CH3COO minus, H minus hydride, and F minus is fluoride. This is Cl minus, which is named as chloride ion. If you want to memorize them, most of the time I have found that students get confused how much charges are present on them. So for the sake of your convenience, I have made a simple sentence and you can learn it as such. You can learn it as, if it is uninegative, you can learn it as, so the sentence is, O seniors, broom, AC house floor, clean. This will help you to remind, O is reminding you OH, that is with the minus. Cn is going to remind you for the Cn minus. Br is reminding you for the bromide. AC is reminding you for the acetate. H is reminding for the hydride. F for the fluoride and Cl for the chloride. And you just remember this is for the uninegative ions. OH, Cn, Br, acetate, H minus, F minus and Cl. All these ions are negative ions, uninegative ions. O seniors, broom the AC house, floor clean. This will remind you for the negative minus ions. If we talk about the dinegative ions are sulfide, S minus 2, oxide, O minus 2, and peroxide, that is O2 minus 2. You can memorize these dinegative ions by using a simple code, symbolic code, and that is SO2O2. This code is representing that this sulfur and oxygen is having minus 2 charge on them, whereas this O2 is also having 2 minus charge on them. It is just to memorize you. There is no connection with the actual text of the books. So this is we are talking about the trinegative ions. Trinegative ions, the most common trinegative ions are N3 minus and P3 minus. N3 minus nitride and P3 minus is phosphide. You can memorize them by using MP3, but here it is NP3. So it is indicating simply here that nitrogen and phosphorus are having -3 charge on them. So there is no connection with that, but this is NP3, just to make it easy for you, just to let you memorize these things. Now let us talk about the special anions called oxoanions. These oxoanions are very common and you have seen them many times and you recognize them also, but they are slightly confusing. Here I am writing down the special category of anions which are ending their name by the suffix called -ate. And these common anions are nitrate, sulfate, phosphate and carbonate. Here is one more kind of ions are there which are resembling with them in their formula, and they are ending their names with the -ite. I am writing down the formula: NO2 minus, SO3 2 minus, PO3 3 minus, and so on. These are the common category we are discussing about, which are very common and are there in the syllabus in the 9th and 10th standard. So here it is nitrate. The name of this anion is nitrate. This is sulfate, phosphate and carbonate. Here these are nitrite, sulfite and phosphite. In this particular row you can observe that their names are ending with the -ates. So this is nitrate, sulfate, phosphate and carbonate, whereas this side we are having the names which are ending from -ite, nitrite, sulfite, phosphite. And if you all observe these formula of these ions, you will find out that ites are only difference, ites and ades are different only in terms of the oxygen. If you remove one of the oxygen from the ades, you will get the ites. Let me show you this. NO3. Remove one oxygen atom from NO3 and you will get the ite, NO2. So you can easily convert the ate into the ite by the removal of one oxygen from the formula. So NO3 minus is nitrate, NO2 minus is nitrite. On the same pattern, I can remove one oxygen from the sulfate and this sulfate will be converting into sulfide. So SO4 2 minus is sulfate and also 3 2 minus is sulfide. And same is applying to the phosphate ion also. So this is PO4 4 3 minus is phosphate. Remove one oxygen and there is PO3 3 minus is phosphide. So you can easily convert these ate ions into the ite ions and you can recognize them easily. Okay students, now I hope that all of you are very familiar with the cations and anions, and you are knowing that the cations are the positive and anions are the negative species which ultimately combine and neutralize each other in such a manner so that to complete the compound with no charge on it. So here I am taking the cations and anions and going to make the formula. Let us see how a compound is formed by the combination of anions and cations. Here I am taking a very common cation and that is sodium. So here it is Na plus with the charges on them. On the other hand side I am taking another anion which is OH with the charges present on it. Write down the charges present on these particular anion and cation after these, that is 1 plus on the sodium and 1 minus on the OH minus. Cross multiply the charges present on them, that is you will get sodium multiplied with the 1 and OH multiplied with the 1. So ultimately 1 and 1 is no need to write down, or they will be cancelled out. I can write down the formula made up by the combination of sodium and hydroxide ion as NaOH, and the name of this compound will be sodium hydroxide. Let us make the another formula by using the another kind of anions and cations. Here I am taking another cation, that is magnesium. This is symbolized as Mg plus 2. Here I am taking another anion, that is N-3, which is nitride N-3. So this is magnesium having 2 charge on them, right down here at the downside. This is nitride, which is having 3 minus charge on them, on it, and that is 3 you have to write down here. Cross multiply the charges of these elements, of these ions, with each other, and you will get what? Mg is multiplied with the 3, so it becomes Mg3, and nitrite is multiplied with the 2, and so it becomes Mg3 and 2. And the formula of magnesium nitride will be Mg3 and 2. The name of the compound will obviously be magnesium nitride. Now let us have iron here from the cation. Iron is Fe plus 2. On the other hand side, I am taking oxide ion. What it is? O2 minus. So here the charge on the iron is 2. Write down after the iron. Charge on the oxide is minus 2. Write down after the oxygen. Cross multiply the charges on them, and you will get Fe2O2. These will be cancelled out, and the formula becomes FeO, and the compound will be Fe plus 2. As we have already discussed, iron shows 2 valencies, Fe plus 2 and Fe plus 3, and less valency is shown by this. 2 is the less, so it will be us. So the compound here which is formed is ferrous oxide. Now let us have one more, last but not the least, that is aluminium. Here I am taking aluminium, Al plus 3, and here I am going to combine it with the nitrate, NO3 1 minus. Let us write down charges present on the aluminium, 3, charge present on the nitrate, 1. Cross multiply both of them, the charges will be cross multiplied, and you will get Al multiplied with the 1, NO3 multiplied with the 3. So the formula becomes AlNO3 whole thrice, and the name of this compound will be aluminium nitrate. So students, now I hope that all of you have learned how to make the compounds by using the cations and the anions. So the main thing is, you learn this list of the anions and the list of the cations. You will just memorize them by taking my help, the video. See to the video, observe the things which are being told to you, and learn the names of cations and anions. Take care that the charges present on the cations and the charges present on the anion should be very nicely done. Otherwise, they will create a problem while writing down the formula. So, good luck to you. Thank you.